Hello, my name is Roger Stanton, and this is a presentation on evolution and climate change. And the topic I chose was the effects of climate on immunity and the emergence and reemergence of infectious diseases. The article is entitled Immunity and the Emergence of Virulent Pathogens from the Elsevier Journal entitled Infection, Genetics, and Evolution. The article was written by Gabriel Sorkai, Stéphane Cornier, and Bruno Favrier. First, I'm going to give you a little background on what immunity and pathogens are. Immunity is the body's natural defense. It's the first to take care of and contain any foreign pathogens, and your immune system is the most environmental factor for pathogens to cope with. Virulence is the effect a pathogen has on a host mortality, and it is measured by the host mortality rate. Virulence is also a maladaptive trait for pathogens, and the mortality measured by reproduction and multiplication rates. The first main point I'm going to cover is the pollution and the effects on climate, and we will look into the pollutants' effects, pathogen vigor on hosts. Pollution is defined as the presence in or introduction into an environment of a substance or thing that has harmful or poisonous effects. The effects of pollution that has on climate change includes the production of smog, which is a mixture of violent organic compounds and oxides of nitrogen, and UVB radiation particles. These list of factors brings us to the discussion of greenhouse gases. Greenhouse gases come from the burning of fossil fuels, industry, land clearing, and agriculture. These gases trap heat into our atmosphere and leads to climate change. With the increase of temperature, increases the multiplication and reproduction of pathogens while it decreases our immune response. Pollution therefore has not only a direct effect on our immune system, but an added effect on climate, which causes the host to become a more ideal place for infectious diseases. The hypothesis of this article is climate change affects the host immune response, causing the host immune system to be one factor that drives the emergence of pathogens and shape their evolution. The methodology is a closer look into the immunity response in the host. Climate change causes temperature rise, which leads to pollutants not being able to escape our atmosphere. This leads to an adverse effect on our immune system, weakening our response to infectious diseases or immune suppression. In this journal, there was an observation that described the pollutants in the immune system of honeybees. The decline of honeybees supported the hypothesis that climate change affects the host's immune response, causing the host to be one factor that drives the emergence of pathogens. Probably the most compelling role of climate change from pollutants and the emergence of infectious diseases was the decline of honeybees. It was clear from this observation that pathogens such as paralysis viruses, Kashmir bee virus, and deformed wing virus, also known as pneumonia, were the most important cause of colony loss. The virus were able to attack the immune system of the host because the bees were introduced to a certain pesticide in the air due to pollution, which weakened the immune response to the virus, causing the virus to evolve into a stronger strain and spread throughout the colonies of bees, which increased the mortality rate of bees. It was concluded that the emergence of infectious diseases or pathogens might be facing a novel immunological environment due to climate change in which they are able to adapt. Immune functions will also become a common feature for organisms due to exposure of immunotoxins compounds found in pollutants. These results could possibly predict the immune functions on the emergence of pathogens and predict the evolutionary trajectory of infectious diseases or pathogens. My research project question is, what evolutionary aspect would pathogens go through according to immune response with vaccines given to a host, and how would the immune system react to the stronger pathogen strain post-vaccination? My proposed methods include collecting a sample of a virus strain. I would inject a specimen with this virus strain. I would have two groups, one with the virus strain and a vaccine, and a control group with neither. I will repeat the testing with the extracting of the previous virus to test if the virus strain overcame the immune response with the vaccine. I will record the mortality rate of the virus strain without a host to see if the virus strain increased in strength or virulence. I would collect data from the previous recorded steps, and then I would observe the specimen response to the either weakened strain of virus or the increased strain of virus. My hypothesis is that there would be a significant change in virus strain as it adapts to the host that has been vaccinated. Basically, the virus will overcome the immune response of a vaccinated host and evolve into a stronger strain of virus. My null hypothesis is there would be no evolutionary change of the virus strain, showing that the virus strain cannot overcome a vaccinated host, basically saying that the virus does not increase in strength, but more so is susceptible to the immune response. My conclusion and results include the fail to reject the null hypothesis and rejecting the null hypothesis. To fail to reject the null hypothesis, the vaccine treatment was unsuccessful, showing a stronger strain of virus and a weakened immune response. To reject the null hypothesis, the virus strain is contained by the vaccinated host and no increase of the virus strain or virulence. This is a pretty big deal because some pathogens can outdo current vaccines and cause increased mortality rate, and this leads to an evolutionary takeover of viruses. As viruses evolve, our immune system evolves, but there's so many factors, including our climate change, which is caused by pollutants and greenhouse gases, that take away from our immune system that doesn't have too much of a negative effect on viruses. Because temperature rise in viruses includes higher multiplication rates and higher reproductive rates, which is what a virus lives off of. So they're able to reproduce, and multiply faster than our immune system. In a sense, it's an evolutionary takeover of viruses, and we are then under viruses as they'll be able to kill us off faster without any aid, and our aid of vaccines wouldn't be able to help our immune response to get over that current evolutionary takeover of viruses. That is my presentation. Thank you for taking the time out to listen to it. Have a good day.